This is a small video tutorial about methodology number 2 developed in the ePANACEA project. In this methodology, we implement a simplified method based on monthly calculations intervals in order to get the different indicators that are used in the EPCs. We will follow the following index. First, we will start with the login and starting a new project. Then we will see how to introduce the general data, then how to define new schedules. Then we will go to introducing new elements of the envelope, how to define the walls, the floor, the ceilings, and also the HVAC systems. And then we will go to see how to introduce the lighting equipment that are present in our building. Then we will introduce other equipment. This is how we introduce the energy equipment consumption that is not related with the EPBD. Then we will go to introduce the energy consumption that is reported in the energy bills. We will also see how to make a small smart readiness indicator analysis. And then we will go to the results and the calibration process. And finally, we will see how can we get some other results that can be very useful when we are carrying an energy assessment. The very first thing to do is to enter your credentials in order to log in to the system. Once you are inside the application, you have two options. You have the option to start with a new project, or maybe you can select an existing project in order to modify it or in order to make a copy and start from an existing project. Maybe you already have defined some schedules that are very useful for the new project, so you can copy them. You can copy an existing project in order to start from that. I think it's everything is really intuitive. Yeah, you only have to fill the forms that are in the different tabs. In this case, we have to fill okay, this is administrative data about the audit date and about the dates of the starting and ending of the analyzed period. Here in location data, we need, for example, it's important to enter the floor area of the project, the floor ceiling height, and the construction type. This is for the thermal inertia of the building. In this area, you have to select a weather field, but for selecting a weather field, first you have to select your country. For example, if I choose Germany, I will have the weather data from Germany. If I choose Spain, I will have the weather data from the different locations in Spain. Then here you have to enter the general ventilation rate for this building. In this case, we have 1 air change per hour. This ventilation rate is modified with the following ventilation schedule. Later, we will see how these schedules are defined, but we already have some predefined schedules, so it's easy to start a new project using those predefined schedules that we have for the ventilation, for the heating thermostat, and for the cooling thermostat, and also for the loads schedule. So I recommend to start using predefined schedules, and maybe later, when once you have entered the envelope, once you have entered the different systems, and you start the calibration process with the reality, then you modify these schedules eh, so they fit best to the reality. In the next tab, we have the schedules. Okay, these are the different functionalities that we have to work with the schedules. For example, if I want to know how the residential heating thermostat is done, how is defined this schedule, what we see is that we have three different types of days across the year. We have gray days, we have red days, and we have orange days. And how is, for example, a gray day? Is defined here, is defined in this row. Okay, gray days start from the 1st of January to the 31st of May. They apply to all the days in the week. And if we want to see how these are defined, I click in Edit. And here we can see that the heating thermostat schedule is defined having 70 degrees during the first hours in the day, during the night. Then we have 20 degrees for the thermostat from 8 a.m. to 11 p.m. And then it comes back at 11 p.m., comes back to 17 degrees. We can really in this we cannot change this schedule here because it's a predefined schedule. But if we want to modify it, first we have to make a copy and then change the copy. If we make a copy, just we click there. Okay, the new name, it will have the suffix copy, and then in this case I can change the different values. For example, if I don't want to have any heating at all during the night, I will change this 70 degrees to 0 degrees. And then when I save it, I will have a new schedule that is slightly different to the original schedule that we have defined. Okay, there is no limit in the um, in the number of days types that we can have in a schedule. This way of defining schedules is very similar to the way we define schedules in OpenStudio. Going back, the next tab in facility is where we are going to define the envelope and the HVAC systems here. In order to define the envelope, uh, it's optional. uh, we can also define the different spaces that we have in our building. Really, it's not necessary, but we can do it. So, for example, in this example, we have this wall uh, that is hanging from this bedroom space, but it could also be hanging from the envelope level. So, okay, we can choose to define the spaces and the thermal zones, or we can choose to define the envelope directly from the envelope. If we want to define zones and spaces, we just have to select here zone and then click new item. And then here we will define, I don't know, we will define new thermal zone. We will have to introduce an area, 10 square meters, for example, and then we have two options here. If we leave the fields blank, uh, the heating load will come from the general data that we have defined from the project. For example, if I don't define a heating thermostat schedule, the general heating thermostat schedule that we have defined in project data will apply. But if we want to have a different heating thermostat for this specific thermal zone, I will have to change and select a new one. If I click here Save, we will have here the new thermal zone. I'm going to delete it just with the right button, and if I choose delete, I can delete that thermal zone. It's more or less the same with the spaces. Okay, the hierarchy is envelope, zone, and space, and then envelopes. Okay, but I insist, zone and space are not mandatory. They are optional. You can use them or not in order to define your envelope. If I want to define a new envelope, I will choose here envelope, and then I have to select a few more things. What type of surface? Okay, wall, roof, floor, interior partition, or an adiabatic wall. I think they are self-explained. Okay, a wall can be in contact with the outdoors or can be in contact with the ground. And we have the default properties, thermal properties, or you can use estimated properties in order to define the isolation thickness, for example. Okay, let's check it with an example. I'm going to introduce a new item of the wall type. I'm going to introduce it, for example, to the bathroom number 1. I have to define the dimensions, let's say 2 by 3 meters. I have to define the orientation. I have to define the number of pillars we have in that wall. Let's suppose we don't have any column there. Let's suppose we have some thermal insulation that is EPS with a thickness of 0.1, for example. And then I click Save. So now, as you can see, we have our new wall that is hanging from the bathroom. Okay, I don't want to change this example, so I am going to delete it. And now, okay, and it's more or less the same with the it's more or less the same with the heating and air conditioning systems. In this case, I already have a boiler that is covering all the energy needs that we have for heating in this building. If I want to introduce an air conditioning for this building, I will we will work very similar to what we have done in the envelope. We will select the HVAC system, we will select the service that we are we are working for. Let's say heating and cooling equipment. Let's suppose we have a variable flow heat pump, and we introduce a new one. Equipment age. Okay, this uh, if the equipment is older, the proposed COP and EER rates are worse. Let's suppose we are going to introduce this only for bedroom number one, and that's all we need to introduce. When we click Save, now in our bedroom we have an air conditioning that is covering those heating and cooling needs. I am going to delete it again, so I leave everything as it was. In the next tab, we are going to introduce the lighting systems. Okay, in this case, we have introduced all the lights of the building. Okay, in this case, it's a flat. All the lights of the house, of the flat, in just one entry. We can edit in order to see how it works. Okay, we have to define a schedule. In this case, we have used a predefined schedule that is okay, that is proposed for residential buildings. Okay, this schedule defines when the lights are on, when the lights are off, or when the lights are at 10% or 50% or 100% on. Here we are going to define the lighting power of all the lights, and in this and here we are going to define the lighting technology. Okay, this is useful in order to automatically propose energy efficiency measures. We have to know what is the technology that is being used here in order to know if we can have a better system or not. In this tab, in other equipment, we can introduce other equipment that are not being defined in the facility tab. For example, um, the TV sets, the washing machine, this kind of equipment. We have introduced it in an entry that we have called appliances. Let's see how it's done. I click here in Edit. We introduce the name, we introduce the power, and we introduce a load schedule and a use schedule. Use schedule is the availability, what hours the equipment is available and what hours the equipment is not available. Okay, and sometimes happens that at some hours some equipments are on, but they are not consuming the full power they can consume. So this is the load schedule. At the end of the day, the energy consumption is the multiplication of the power by the values of the load schedule and by the values we have defined in the use schedule. In this case, as we don't know the exact distribution of the energy consumption of the appliances, we have chosen to select a constant schedule that is always on. It's always core power. And we have supposed that we have a mean consumption of 100 watts every hour. So at the end, this will result in an energy consumption of about 876 kilowatt hours, because a year has 8,760 hours. If you multiply them by zero point 0.1, you will get that value. You will get 876 kilowatt hours. In this case, we have also used the tag. In this case, okay, we have defined a few tags that are needed for methodology number one. We have to know what's the energy consumption, what are the equipment that are consuming for appliances, for cooking, for domestic hot water, for pumps, for vehicles, for ventilations. So when you define the equipment that is consuming energy for cooking, you will have to select the cooking tag. So, okay, uh, so we can know, we can separate the different kinds of equipment. Of course, it's also important to define the fuel. In this case, we have chosen electricity. Maybe if you are for another equipment, you are using another fuel. Okay, you can have different fuels in the same project. Okay, and for domestic hot water, it's more or less the same. Yeah. We have estimated that in this building we have a mean power consumption of 0.217. So, okay, the total annual energy consumption is equivalent to have a mean power of 0.217 kilowatts. So we define this mean value, and then we define the loads and the use schedule as always on. And in order to know that this is domestic hot water consumption, we have to select the tab domestic hot water. Then we go to the energy bills. In this case, we have energy bills for electricity and for natural gas. The very first thing to do is to define what we call a contract. To do so, we will click here in New, and uh, when you uh, when you click in New, you will have to fulfill the supplier, the fuel, and this is especially important for electricity energy consumptions. Sometimes in your bill you have the energy consumptions in different periods of the month. Or sometimes, as is the case, you have just one consumption for the whole month. Uh, there is no discrimination of what energy has been consumed maybe during the peak hours or during the off-peak hours. Maybe the electricity has always the same price at all the hours. Okay, and this is in Spain. If you have a constant price for the whole month, okay, that is what we call a tariff 2.08. and is defined with a schedule. If we have a look at its schedule, what we will see is a flat schedule with all ones at the different times. If we have a schedule with values 1 and 2 and 3, okay, that will be the different periods that we have in a day for the for the energy consumption. But in this case, this schedule defines it's always on one, so there is only one period in that bill. How we introduce the different bills? Okay, the first thing to do is to introduce what we call a fictitious bill uh, that defines the starting period. Uh, so, in many cases, this date will be the starting date of the first bill you have. In this case, is in the 1st of January. And I introduce here in this fictitious bill a consumption of 0. If I go back and then I introduce the bill number 1, that is at the end of the main, and this is not going to be an empty. Okay, this is the real consumption that has been, is the energy consumption that has been produced between these 2 days, and so on. Okay. Uh, in this case, we have introduced the 12 bills. It will also be possible to introduce just 2 bills. I could delete this one, 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 and I could introduce only the initial bill and the end of the year bill. Of course, in this case, I will have to introduce here not the December consumption, but the aggregated consumption all the of different from the all months of the year. So, in the next step, we are going to the SRI, and these are just a few forms that you have to fulfill in order to see what what functionality are present in your building. For the heating service, the domestic hot water service, the cooling service, and so on. So when we get to methodology number 2, we have the results. We have the results of the natural gas in primary energy and final energy and electricity. And here we have the results of the calibrations. In this case, we have an error of about 20%, 19.22% of normalized mean bias error. We will have a look at it a bit later. And we also have here a link in order to see these results. Okay, I think I can traduce to English. Okay, the primary energy consumptions, the different energy vectors, and okay, how this consumption is being distributed, and so on. So I think this can be useful in order to analyze what's going on in your building. But also we have also another functionality in order to see how um, how things are being done. If you are here in other equipment, you can make a graph, and here we can see in the green line in the green line are the energy bills, uh, the electricity energy consumption that we have in the energy bills. And here we have the equipment and the equipment consumption plus the air conditioning and plus the lighting. Okay, so it's more or less here. And we could do the same with the natural gas. Okay, so in here in methodology number 2, so the calibration is not okay because we have an error of almost 20%. So in order to improve the fitting between the model and the reality, we have a couple of options. Here, the program suggests that we increase the equipment with a factor of 1.58, or we increase the lighting energy consumption by a factor of 1.4. The decision should be based on the experience of the person that is carrying out the energy assessment. Uh, in this case, we are just increasing the lighting energy consumption by this factor. So we are going to lighting systems. We are going to edit the lighting system. And in order to increase the energy consumption of this equipment, we have two options. Uh, we can increase the power of the lighting equipment, or we can go to this schedule, make a copy, and increase the values that we have in the schedule. I think it's much more simple just to change this 300 watts by to increase them by a factor of 1.2 or 1.5, sorry. That should be 420 watts. And I just click save, and then I go back to M2 results. And I guess this should already be fitted. So now this is a model that is perfectly adjusted in the annual basis to the energy bills. We can see the same if we go to other equipment and we select fuel electricity, and now we make a graph. I click cumulative energy consumptions, and I have mentioned before the green line is the energy bills, and the blue line is the equipment consumption plus the lighting and all. And this is okay. This is fitting in an annual basis. Also, there are some difference in the monthly results. And finally, we have here the results. Here we can see a graph for the energy needs, heating energy needs. There is no cooling needs in this project. And we can also see how the energy is being used in this project. Here we have the primary energy. This is due to the natural gas, and this one is due to the electricity. So we have natural gas for the HVAC consumption and for the domestic hot water. And also we have electricity for equipment and lighting. Here on the left, we have the primary energy, and here on the right, we have the needs. Between the primary energy and the needs, we have the um, the performance of the HVAC systems, and we have the the coefficients to change from final energy to primary energy. We also have here the results of the SRI and from the different um, impacts on comfort, energy efficiency, and so on. So that's all. If you have any questions, okay, you can mail us and we will try to help you.